Hello and welcome back to Calculus 2, section 7.5, integration by partial fraction decomposition. So this technique is studied in either algebra or precalculus, and it's used to find two fractions that could add into a polynomial that you have at hand. So let me give you an example. Let's say you have 3 over x plus 2, and you are adding to it 5 over x minus 1. In algebra, which will go this way, what you do is you find the common denominator. In this case would be x plus 2, x minus 1. And there will be 3x minus 1 plus 5x plus 2. Then you will FOIL and combine like terms. So we have 3x plus 5x is 8x. And then negative 3 plus 10 is positive 7. And all of that is divided by x plus 2 and then x minus 1. So we start with two rational functions, and then we perform algebra, right? Find the common denominator, so we are able to add them, and in the end we get this one rational function. Partial fraction decomposition is a method to go back. So by performing partial fraction decomposition, you will be able to take this 8x plus 7 over this, and after doing everything properly, obtain the two fractions on the left. So now that procedure is actually not calculus based, it's algebra based. And then you will solve that, and then if something like this is within the integral, you will be able to integrate. Because observe this, I'm going to erase these things, but just for the example here, if you are supposed to integrate this expression, it will be not possible in this form. But if you are aware that this particular integrand is equivalent to the sum of these two, then you can integrate each one of these independently. You see that both of these are very easy ln integrations. The first one will be 3 ln of absolute x plus 2, and the second one is 5 ln of absolute x plus 1, x minus 1. So it's fairly easy to integrate 2 on the left and not possible to integrate 1 on the right, which is why we learn this particular method. Now let's grind through algebra just as an example, and then we'll do calculus examples afterwards where we have to perform this. So we start by making a setup for our partial fraction decomposition. And that setup is that if you see linear terms, you will write them like this. And now your job is to figure out what A and B are. Now clearly, once we are done, they better be 3 and 5. Otherwise, we broke mathematics, we go home. So now, how would you do this? Well, the only thing that you can do on the right-hand side is to actually perform common denominator. So add these two fractions. So it's going to be x plus 2, x minus 1. And then you have a times x minus 1 plus b times x plus 2, which further is ax minus a plus bx plus 2b divided by x plus 2x minus 1. And now if you pay attention, you see that this and this is the same expression. So from that equality there, we are able to write 8x plus 7 is equal to ax minus a plus bx plus 2b. Denominators obviously cancel because both sides have the same denominator. So if you multiply through by that denominator, it cancels on both sides. So technically, you set this up, you find the common denominator and you solve it as best as you can. And once you're done with that, this expression and that expression are the same because they're connected with equal signs everywhere. So now you have these two expressions being the same with the same denominator. By multiplying both sides by the denominator, denominator disappears or cancels out, and you have 8x plus 7 is equal to this mess with a's and b's. Now,
I don't understand the reasoning. I apologize for a times x minus 1 instead of a plus b.
for common denominator, right?
I understand what is the denominator.
So you multiply by x minus 1 on both, then you multiply by x plus 2 both, which is the...
Oh, I see where it comes from. Sorry.
Good.
I thought that was really good, and I didn't see the flip.
So now, I'm going to pull all of the terms that have x in them. So it's going to be a plus b times x, and then we have minus a plus 2b. I'm going to write this in blood over here. Now, we compare coefficients. 8 with a plus b, and 7 with the rest. So you have a coefficients of x and constants. That gives us two equations. I know that a plus b is 8, and negative a plus 2b is 7. And I will color code where these equations are coming from. So once we have this equation from the equality of two sides, we will factor out terms with x, put them together, and the constant, put them together, and simply say if these two expressions are to be equal, coefficient of x better be the same as the coefficient of x, and the constant here better be the same as the constant, which gives us our two equations. Now you use whatever magic you have in your sleeve to solve that system. Elimination, or substitution, or you throw some bones and look at them. I don't care. Just get the numbers. And those a and b, guys, better be 3 and 5 when you're done. So in this case, obviously, we are going to add equations immediately because we have a setup for it, right? A and negative a cancel immediately, giving us 3b is equal to 15, from where b is 5. And immediately going back to the first equation, a must be 3 because 5 plus, right? 3 plus 5 is 8. So there they are, 3 and 5. And those were the numbers that we were looking for. So, oh, by the way, where does this problem end? This problem ends when you actually write 3 over x plus 2 plus 5 over x minus 1. Done. So we successfully decomposed one of those rational functions, and now we have two fractions, new rational functions, and those should be easier to integrate. So let's talk about what is to be memorized so that you can do this, and then do a few examples of just setting this up, and then do a few examples where we do full calculation. Once you figure out the pattern, I understand this is a lengthy procedure and this is just to set up the integral so that you can finally do calculus. I understand it's lengthy, but once you figure out the pattern, you will see that this is not labeled as hard. It's labeled as one of those annoying procedures, right? It takes time. You have to be extra careful not to forget any minus signs or anything like that. So it goes smoothly. So let's see what we have to memorize. So memorize setups. If the expression is something over x plus minus c, in the setup you will use a over x plus minus c. So x plus 1, x minus 2, just x. Whatever you come up with, if it's a linear term, it could be just x, it could be x plus minus any number. The setup is a over the same thing. If you have squared situation, then you will be setting up a of x plus minus c squared plus b over x plus minus c. Next, if you have an unfactorable quadratic, so let's say you have x squared plus 100. You can't factor that any further. It's x squared plus 100. That factors over complex numbers. So in that case, you are stuck with a quadratic down there. It should have its own setup, and it does, which is ax plus b divided by that unfactorable quadratic. And then we have the squared version of it, so repeated. Which will give us ax plus b over ax squared plus bx plus c, everything squared, plus cx plus d divided by ax squared plus bx plus c. Precalculus 1, I believe, section 7.3, if you have a chili pepper book.
Yeah.
I believe 7.3 in Blitzer Precalculus. If you do not have the book, Tutoring Center has the book, Library has the book on reserve. You can use in both of those materials. I believe 2 hours, right? 2 hours max. You can use the book in Tutoring Center, or 2 hours. Then they come with a stick and take the book back. So 1 hour, 59 minutes, right? We say from the stick. Okay. So this is what you are memorizing. A few tips that you might already picked up on. Observe that the symmetry. Single, single, squared, squared and single, squared, squared and single. See that? So the same progression in these formulas. Another part that you can notice is that this is x to the first power, no x, which means x to the 0th power. This is x squared, and then there is x. So it's always one power less. So there are a few things that you might be able to utilize to see how this stuff works. But you will have to know these, because if you don't know them, you can't set up the problem to do partial fractional decomposition. And if you don't do partial fractional decomposition, you can't integrate. So you must know these. Now, for exam, I am going to have two separate questions. One question that is up to at most 3 variables, so 2 or 3 variables, A, B, C, or just A, B, for you to solve the entire problem starting from the integral decomposition and then integrals of 2 or 3 integrals you get, and you're done. So that's one problem. The other problem could have 6 or 7 variables. You will just be setting it up. The problem will clearly state solve the integral, which is where you have to go through the whole thing, or the problem will say just set up. I actually had one year, I put in right next to it, do not solve. But I guess for some reason students don't like to read every word. So I started getting questions during the exam, right, which is kind of annoying, right? Do we have to solve this? And you see 7 by 7 system. I mean, no. 7 by 7 system is going to take you an hour. Why? It says do not solve, but then there was a word solve, and then immediately, right, let me just check even though it says so. So one problem to set up, that's the one that's going to have million variables, and then one that it's going to have 2 or 3. Now, any combination of these can be given. You see, if you get, let's say, x squared plus 4, that's unfactorable. X squared plus 4 squared. That will immediately give you 4 variables. And let's say that was pre-multiplied by x minus 2 squared. Well, that will introduce another 2, so now you have 6 variables. And let's say there was x in front of everything, that's the 7th variable. So you can link and chain as many of these as you want. They all factor into something like that. So knowing all these 4 cases covers everything. And then obviously for purposes of calculation, I believe the homework will go and ask you to solve the 6th order system. Not a big deal, you have your graphing calculator, just plug in the matrix, row, reduce, and you're done. But on the exam, having a 6 by 6 solution, right, matrix, and then no calculator to do it, might take a long time, and that's why there will be 2 separate problems for partial fraction decomposition. Something that is quick to solve and something to just set. I'm sorry?
So it'll be very obvious.
Yes, because the directions will say, right, solve the integral or just set up. So let's work on some setups to understand how these setups work. So say you have integral of x plus 3, x minus 1 dx. Now observe, I'm writing a blah up there because it really doesn't matter what's up there. We are only concerned with setting it up, so we are not actually going to compute anything, so I don't have to think about anything up there, just leave it. So this is going to be the integral of a over x plus, next one is again linear. A is already used up, so we're going to go with b, x plus 3, plus, so now a and b are used up, so c over x minus 1. All of that in parentheses, dx. That's it. You're done.
Done. That's it.
If you are just setting up, you are done. Which one do we use? We use this one 3 times. We use the first one 3 times because if you look at the denominator, linear, linear, linear. Next example. Let's say you have x minus 2 times x squared plus 4 dx. Well, the first one is linear, so we know it's a over x minus 2. And then plus, the second one is unfactorable quadratic, which means bx plus c. And we're done. So we use this one and the first one. We use the first one for the linear and the third one for the unfactorable quadratic. Three. Try this one on your own.
Is that debate party after school? Like pizza, you can sit and watch the debate. You get the or you can just eat pizza. Or you can just eat pizza.
Is that now?
It's at 9.
Or is it 9? Oh, that's after the class.
Yeah.
Yeah, I'm just gonna go home play.
I still love it. But you have to choose. What? You have to choose because millionaires get the president. You have to choose. I'll write out this simple logic. This is the simple logic behind this. Between Hillary and Trump, which one is more likely to push the ball? Trump. All right, so vote Hillary. No, he's still going to get the money. Somebody's going to say sausage. Okay. I hate you. Even then, runs business like he's declared bankruptcy so many times. He makes money off of running businesses into the ground and then declaring bankruptcy off of that. Because you
And
can
screw
do
over,
something.
and screw over his vendors.
Yeah.
He's basically pretending.
Trump has never done anything to benefit others. He's only done things to benefit himself. I mean, as a businessman, you're free, like, but as an ethics person to be like the commander in chief, you're not qualified. Of this, what was it, 5 living presidents? None of them said, yeah, this guy should be. That's both Democrat and Republican.
What's the breakdown?
That's the what? The setup?
Yeah.
Alright, it's a over x plus b over x plus 3 squared plus c over x plus 3 plus dx plus e over x squared minus 100.
Gotcha.
Oh, you can factor.
Uh-huh. Yeah. See, this is why I... So, everything that you said until the very last is correct. A over x is good. Plus b over x plus 3 squared, good. Plus c over x plus 3, good. And then, yeah, this one factors. So d over x minus 10, d over x plus 10. E.
Oh, wow.
Yeah, cheap. I know. I couldn't resist. This was communicated through me, not by me. So the voice is in my head. Yes.
Does it matter whether you choose x minus 1, x minus 10 before or after?
No, it doesn't, because they will sort themselves. So whatever number is above plus 10, no matter whether you label it D or E, it will be there.
Oh, that's why, because the other one is, if it's unfactorable.
Unfactorable, yes.
Gotcha. Alright.
Yeah, the one that I had this board.
I'm still somewhat smart.
No, you did well. It's just,
So I have a question.
I'm not the greatest person. Yes.
I'm putting one. So the better strategy for this is to maybe go ahead and factor this out under here again, so you have all your things in place and then do it?
Yes.
Okay.
And I'll write it here. Yes, Mark.
If you have x plus 3 squared, doesn't that make it 2 linear ones?
It's a repeated linear.
So, it's,
So it has its setup.
Huh?
It has its setup.
Why isn't it just b over x plus 3 plus c over x plus 3?
We'll have to look into a proof. Because it's not, I know what you would like to do. You would like to put a over x plus 3 and then b over x plus 3,
Yeah, I think more than one.
but it doesn't work.
Why?
YouTube. Just YouTube approving it.
We'll have to sit afterwards and explain.
Okay.
But it doesn't. All right, next part. Just check this slide. I know.
No, just like why? Yeah.
Is this another setup, or do we actually have to look at it?
No, this is gonna be solved.
Gotcha.
Solve this one using partial fraction decomposition.
And then I got stuff.
So wait, well, this, I mean, then you can just say ax plus b x is equal to 0.
Well,
Yeah, so a plus b has to equal to 0. Put this on top. 3a plus 2b must equal to 3, and then you add the 2.
oh, well, it doesn't matter. It's you try to, right?
Oh no, you add the 2 together. So if you add the 2 together, it doesn't matter. Just
Oh, okay.
4a plus 3b is equal to 3. Then you solve for b, solve for a, and then you find out what it is. So wow, I did it the long way. I did it the long way. Oh no, like I was using substitution. So if you solve for b, but in the sense because I added so I got 4a plus 3b is equal to 3. And so I was gonna solve for b and then plug that in for b because I want to get b is equal to 3 minus 4a. Substitute that into b and you solve for a. Yeah. So I did.
Oh, wait, you're supposed to do it.
Let's see. So what do you because like don't you have to add the 2 together, or you can just use whatever.
Well, because you have two equations, right? You use the same variables.
Yeah. Professor, you can do that. Just multiply the whole equation by -3. Wow.
Yeah, I did the elimination.
Yes.
That's the elimination method.
Not.
Yeah, like I get 2, 3, 3.
No, like I just did
N is equal to negative 3 again.
That just that hurt my feelings just thinking about it. Now I feel like an official idiot.
I know, bro. I'm saying there's some
Let's talk about this problem. We start by factoring denominator. Since both of them are linear, we set up a over x plus 2 and b over x plus 3. And then we start our partial fraction decomposition. Same steps. We equal the 2 from the integrals. And then we start working on the right one by looking for the common denominator. And once we have the common denominator, then we look at the result and the first one, compare the two, same denominators go away, and we are getting this equation here. Once you have this equation, we will factor out terms that have x together, and we will also combine the terms that do not have x together. We will link the coefficients of these and obtain the two equations that we need.
Can you explain that little piece better? I got all the way up to 3 equals that piece right there I got. What's the next piece I'm not getting?
Okay, so next piece is actually from linear algebra, which is the class you can take next. And it says that these two are equivalent as long as the coefficients are the same. So what happened between these two terms is I pulled all x's together on a pile and put all the constants on the pile. And now that piece of, in order for these two polynomials to be the same,
What's the OX?
0x. I don't have any x's.
All right.
So it's a placeholder.
It's
0x.
placeholder.
Yeah, call it a placeholder. So now that I have a placeholder there, I can easily compare the coefficient of x from the left to the coefficient of x from the right. So here is the coefficient from the left compared to coefficient on the right for x's, and this is the constant on the left, the same as the constant on the right. Both of those conditions have to hold in order for these two polynomials to be equal to each other. That's it? Yes.
You said you could like interchange like the A and B, right? Like it doesn't really matter which one's which.
No.
When I got the integral, I got 3 ln x plus 30 minus 3 ln x plus 2. So I did a lot of that. You got the opposite.
I got b as -3 as well.
Yeah, that's my issue.
Something where, somewhere, you just have a minus sign somewhere. You can find it, hopefully. So I will color code now. So the coefficient of x is the same as coefficient of x, which is red equation. And a constant is the same as constant, which is the blue equation. Yes? This one? Ah, pen, come on. This one. That one is there to solve the system. I decided to solve the system by elimination. I multiplied the entire expression by -3, which gives me this. Then when I add, I eliminate a. Called method of elimination. Also known as Gauss-Jordan elimination, or Jeff elimination, or addition. Three names. No, I could have used -2 as well. Yes.
You should get negative.
If you're not comfortable with that method, use solution. Right? A is equal to -3. Whatever makes you solve the right. That's what you just asked. That was my elimination method. So I wanted to cancel with A's. So I need to multiply by -3, so they cancel. Solving system of equations, either by elimination or by substitution. What else did I offer earlier? I don't know. I offered nothing else. Yeah. Look at. Yeah. Yeah, where did you come from? No. Throw it, yeah. Look at the box. Yeah, it's true. It's messy. I mean, spending a lot of work. Elimination easier. Elimination easier, man. That's why people gave up on all of that stuff. It's much easier to do it this way. No cleanup. Yeah. Nothing smells bad. Why? Oh, I got distracted. Yeah, too. Well, good to know that you have someone to clean up after. Still. But still clean it. Never went like that. The student in question is. All right. Once we obtain A and B, we plug those back in the integral and use U sub. Use U sub to solve, and we're done. Next example. So here's a wonderful example that will take a while. Y plus 1 divided by y cubed plus 2y squared minus 18y. What are we supposed to do? Factor it, exactly. Enjoy. That's what they say in restaurants, right? Right after they bring us food. Enjoy. Yes, y cubed. Mark.
There's a slight lag.
I still can't see it. I'll take your word for it.
Can't miss it.
So what we can do, we can pretend that one of the Y's doesn't exist. There's definitely a Y plus 1. 9 and 2, 6 and 3, 18 and 1. Well, no, but because it's a cube, we have to take out the y first, and then it's y squared plus 2y. Maybe I'm just behind. Once again, I'm going to start the game tonight. Class 8.
Yeah.
So since it's unfactorable, we have to use the other y.
Yes. Yes, it is. I see.
But wait a minute, that's actually not that bad. It's just like, oh, so what? What can you do?
Hey, right?
Oh yeah, I did copy that wrong. Yeah.
Come on, no, no. I already.
That's clearly a 3.
You got it.
Oh, okay.
Yeah.
I feel like you're doing this to like loud.
No, because it's not factorable the other way, and it's probably going to be much worse.
It was pretty obvious.
Oh, you're using pens in Calc2? Come on.
I remember my first.
That's why we have pencils. Oh, no, I did the problem earlier. Correct. And the one before that, the one before that. Oh, I said I did. First problem, 5 so far.
We didn't put anything in multiple alpha, so we can check.
Yeah. So I did 5 correctly, and then messed up 1. So I'm adding 4 lines over here. It's awesome.
That was what you said.
That's a clear surplus right there. And I'll keep track of how many I got wrong. Well, actually, technically, I didn't get this one wrong. I copied it wrong. This is something where you would come to me and say, but I copied wrong, I deserve all 107 points. Yet the problem is still wrong and the bridge is gone and everything is up.
Can you do me a favor?
Yes.
If during the test, somebody raised their hand and you find that you work at all, can you call down to the test and say,
Oh,
make sure they tell me? Thank you. I think it was 20.
Yeah. Oh, so it'll be like plus 6. Minus 3. Right?
you notice that all of these problems all of a sudden take like 30 minutes to do? Next time a student said something, scroll to one of these. Oh my god, but that was so long. You had 5 steps.
Let me teach you the partial fraction decomposition within the integral.
Am I setting this up correctly
Yes.
so far? Oh, I just rewrote it. This is supposed to be a Y in my handwriting. It's just oh, because us, right? Oh, 1. So then how would it be? So, A. Oh, okay. I got it. Yeah, I have to say it. Okay.
Oh, yeah, yeah.
I was there.
Oh my god. Oh my, that is directly stabbed in the heart. Oh, oh, oh my god. I could be injured mortally. Alright, so let's not speak for another week. That look like I solved it?
No, I was like,
Yeah.
they would have taken
Oh, I'm gonna start soon. I'll catch up. Don't worry.
I'm so excited.
Here's the
I don't make sure if I was right. Doesn't make it right.
No, it's not. Certain things are smooth on
You're just gonna write like
See, in this situation,
I already did that once.
except the last one. This one I can't do this position in my head.
There's still algebra station.
Oh, I didn't.
You got for 3 plus 16. No.
Yes.
So you're better. Why?
Just because I'm a hypocrite. I'm very hypocritical.
Oh yeah.
See, now I'm going to do that. Alright, did you say up your equation? The nature of the ABC. Are you just saying that? No, I'm actually.
I can immediately tell you just by looking at the problem, it's obvious that the solution starts with negative 1 over 18 ln of x. That's obvious. But
So it is still negative. It's just minus 3.
Yeah.
27 over 5 ln of x plus 6.
No, I have problems.
Yeah, no, that was.
Or you're concerned now.
Yeah. Like the.
Oh, you're right, it is.
That is the
Yeah,
one.
I was so you just have it because it is beautiful.
Yeah. And then I also did.
I can't. I'm,
Oh, well, actually, no.
So I'm just gonna catch up real quick.
Literally. Well, it took me like 25 minutes. You're about to do in like 2 seconds. I'm just gonna destroy my self-confidence all over.
No coffee.
no.
I'm so sorry. It took me like a year.
Wow. What the?
Oh, it's an algebra overload. That's what it is. It's too much algebra.
Wait. I can't be right. Because mine's supposed to be right. Mine's supposed to be right.
I got a text message.
Hopefully opinions matter.
So A is equal to negative 1/18, right?
So for second equation, it's 1 plus something, so it's isn't it gonna be 1 plus 1.1/6? It's 7/6.
Where?
For the second equation, 3a minus 3b plus 6c.
These ones? 3 plus 6 is 9.
No, the blue one. See the blue equation?
This one?
When you put the a, so you did like just 1/6. Isn't it gonna be 1 plus 1/6?
It is. Oh yeah.
You know what I'm saying?
This over here
Yeah.
is.
Transfer it.
Oh, that's 1/6. So this is 5/6 over here.
No, it's gonna be 7/6 because it's negative 1/6. So it's coming for delta x. It's gonna be plus 1/6.
Like this?
Yeah.
This is. Oh yes, negative 1/6. Yeah, you're right. So 7/6.
Oh, it's a 1. Oh, that's 6.
Well, that just kills this. That's okay. Four over 27.
-5.
Why would we combine something and divide it by 9? Because when you divide by a fraction, that's 9/6. So it'll be 9 times 4 over. So you can do 4 over 2. 4 over 3. No, it would be
saying a lot about.
Wait. Oh.
Can you scroll that up? A little. Here. Right there. I have a question.
Oh, just plug into the original, the A
What would happen if you
plus B
interchange
plus
P
C.
and Y? Like, what if P was P over Y minus P
Well,
and
you
P
can plug
over
into P.
P over Y plus?
You will just get the two terms on the bottom swapped.
So would that be incorrect or doesn't matter?
It's just a different order. It doesn't matter. It's the same. If you are interchanging those values, you're just going to have these two logs interchanged. They're still going to have same coefficient, same everything. They're just going to be in a different order.
So let's see. So B ends up being 5, -5 yeah. How did you get?
That's where the problem begins.
The other way. Down. Somebody's up. Perfect.
I remember my first time. It's not hard. It's so annoying. Yeah.
Unless you are okay with what forward. I know. They're doing this Really? That's false.
Take me out of the after.
Actually, we can calculate that. What were they?
Just himself.
I don't know this guy.
Next one.
Probably unintegrated.
The good thing is that you're enjoying all of this, otherwise it will be very dreadful.
What's it? Is that sounds like something that
And no one threw a tomato. I'm honored. The problem in the textbook is stated with z's. I will change those z's into x's so you are not confusing 2's with z's. It is x plus 1 divided by x times x squared plus 4 dx. Just need to make sure that I'm writing this correctly, because I just have another tick mark over here in the not so good department because I am not adding numbers.
So if you get to 10, does that automatically add like plus 2 points on the exam?
I'm not taking exams, no.
Not for us.
You are unrelated in this matter completely. No, that's the wrong word. Irrelevant is the right word.
Are those supposed to be timelines?
Yeah. Because he decides to write them sideways. That's why.
This is how they're supposed to be done, actually.
I don't like it.
I'm sorry?
Nothing.
There we go.
It's good to be a king.
Martin Luther King
No.
I love that movie.
I haven't seen it. I saw Blazing Saddles. That was an amazing movie.
Yeah.
No, you've never seen Blazing Saddles?
No, it's just like, you guys are born in the wrong
You've
time.
never seen Blazing Saddles?
That was like
No.
an amazing movie.
Oh, you have got to see that.
Well, I'm going to
Also,
go.
ladies and gentlemen,
You have to think about the politics at the time that went into the movie.
my favorite joke in that whole movie was, okay, ladies and gentlemen, for my next impression, Jesse Owens. And then he just runs. Yeah. The guy who's. They were trying to it was a black sheriff. He was the first black sheriff ever. He's like infantry blind, but still black guy keeps stealing money. And they unmasked him and was like, like, I hope these are homework problems, so I don't have to redo that. Homework review.
I got myself a 25 every time I'm doing work.
This is an amazing section. There's a reason why I asked this question.
Question. No, not you. You're just thinking out loud. My bad. It wasn't me. No, you're gonna make me feel stupid. You're gonna make me feel stupid.
No. We're not discussing that. Don't worry about it.
No. X squared plus 4. The factor of that is it's not factor.
It will be x plus 2y, x minus y. Complex.
Complex. Gotcha. Okay.
Pluses are always complex and negatives are not.
Gotcha. Oh wow, it'll just be bx plus 2. X plus dx.
So you want to run so that
How did you solve for A? Oh yeah, you want A.
No, because I just saw it.
Yeah.
Yeah.
And then you see if A or one.
I don't get how people can do shit like this.
No, I like
I was
it.
doing it.
So
I didn't mean it.
I was talking about him.
Oh,
Even after doing it, no shit.
This one, like, this one, take out
I only started doing quantum physics in this
But yeah, I thought everybody was like,
Yes. And look at like the whole record for what math equation looks like.
for A, I got 1/4. C, I got 1. And then for B, I got nothing.
Well, A plus B equals B.
1/4 plus negative 1/4. Yeah. So it's partial. Isn't that just 1/4?
A plus B equals 0, A plus C equals 1.
I forget A plus C.
Because
You separate the two. Oh wait, no. You get negative. It won't. It'll just be C equals 1.
Wait,
So it's A plus B equals 0 and C is equal to 1.
yeah. No, yes, yes.
are you just saying that?
No, no,
I thought like it sounded like the way you said it was like yeah, that's what I got. Like you sounded like super like
Sarcastic.
yeah. I was like wait what? Are you getting serious?
So how do you get A?
And then you solve for X.
Wait, how did you get 1/x²?
Yes, you plug A.
How did we split this?
How did you get A and B?
So A should be only like constant. 14.
And then
Wait a minute. Wait a minute.
Because I forgot about it. That's why I was missing an equation.
yes.
I was missing an equation. So C equals 1.
Hold on.
A equals 1. And A plus B is equal to 0. That's 0. So B is equal to negative 1. So it's A1, B negative 1, C.
Wait, 1/x² plus 1 is
Just use trick sum. Yeah, trick sum. Yeah, because it's my. So they're saying if we have negative x plus 1 over x squared plus 4. But my b is negative 1. Right? Because a is 1, c is 1. So a plus b is equal to 0. How'd you get it as 1? No, because you have to get 4a equals 1. What do you have for 4? You're right, yeah. I'm just the x squared is just so b is negative 1. So I'm just going to write this as plus the integral. Yeah. I got and. So it's ln x plus the integral of negative x over 4 plus 1 all over x squared plus 4 dx. I mean, you have to integrate it.
No, you don't. You integrate the one. So that integral plus the other integral. You can do the integral of both of them again. So as far as I'm concerned, that's an answer.
They can solve it themselves.
You can walk right off to that. Just come on, folks.
You can just keep it as 1 over x plus 4. And the other one negative 1. X squared plus 4. Or
What I've got here.
You have bx plus c. Awesome. Yeah.
All right, cool. And that's actually going to transfer down to there, right?
Eventually, yeah.
Yeah.
More work to be done.
Oh, yeah, I know. But I thought I'd make a placeholder. Because it helps me connect all this in my head.
Yeah.
But you get b is 2x.
I'm not sure how you. Oh, okay.
This had me wondering that there.
Yeah, c is equal to 1. Perfect.
Okay.
Yeah.
All right, it just seemed odd to me.
And just get the b and your b and then some integration.
Get the B.
Yeah, because you have a and c calculated. You
see.
need b, so you can put it together.
So what he did was he took out the 1 over 4 here when it's negative x over 4 over x squared plus 4.
I get negative x over 4. That can't be coefficient.
Wait, why can't it be
wait.
that? That's when I'm integrating. So then going back a few steps,
Okay.
there's 1 over 4 times x.
Okay,
But
so
what I did was I multiplied by the reciprocal instead of taking out 1 over 4.
yeah,
And then I set equal to that, so I set u equal to that. Is that the same thing?
that's the same thing. And then you are doing what?
And then once I did that, I did u sub.
Awesome.
There's going to be C and C++. It's a programming language. You didn't build them.
I don't know.
It's like you can use it to build the Unix. I think that Unix Apple's operating systems for C. Microsoft was building a basic C++.
Can you help me figure out what this thing is? I just saw this on $3,000. Yeah, this is like a virtual reality. Yes, pretty much instead of being a desktop, you file that one. Well, because there's a processor, so just like, you model is it's already there, because it will be like, they're kind of so HTC Vive is so and install software. If you look at if you install their software, then practically only all the information from that. So they're gonna change it. No, but like, if you say you build an app, right? Yeah, they can fix it. Yeah, that's what we want. Yeah,
I was like the beginning, because I used started.
that one, I saw people doing it. Samsung Live. Samsung, they're kind of HTC Vive versions. Yeah.
I'm gonna try out the.
It's so good. Yeah, this one I think is 3,000 by 3,000.
Oh yeah.
Please tell me the same thing I did.
I don't
Please tell me the same thing I did.
How did he get in?
That's your eyes out. No. Yes, it's Oh, because of the one here. So you separate. Yeah, that's not right.
you can't.
And the $1 million question. That one at the end. You either know it or you have to crank trig sub, right? Inverse tangent. And this is why I told you, out of the entire list in 7.1, I asked you to memorize only one of them. And this is the reason. And if you take differential equations, you are going to run into Laplace transforms, and you will do inverse Laplace transforms, and it will be full of this situation. Inverse Laplace transforms require partial fraction decomposition, and some of the answers will be the inverse tangent, which is the last integral we have over here, which is 1/2 tangent inverse of x over 2, and then we have plus c. So out of the entire 7.1 list, for the basic integrals, all 6 trig functions, I ask you to remember only inverse tangent, and there it is. Now, if you don't know it, it's going to be another half a page. You draw a little triangle, you assign little things, and eventually, there it is, inverse tangent as the answer. Yes?
You assign the triangle, there's no route.
There's no, you can because when you are supposed to substitute it back, you will be substituting it not as a radical but as a radical squared, which is technically whatever trig function you get, you just put it as. Maybe we should do a problem like that just because. Maybe we should do a problem like that. So when you see 1 over x squared plus a number squared there, a squared, that's inverse tangent. 1 over a, inverse tangent of x over a. So check out that on the 7.1 basic integrals.
So that U sub is for
U sub is this is a U sub for the middle one. That's why it's in red. Color coded. This one is
The 2 on the denominator comes square root of 4.
yes. So if that's 1, you have a 1 and a 1. If it's 9, it's 3 and 3. Great. So this is a partial fraction decomposition, guys. You will hopefully do another 10 problems at home? I mean, weekend's coming up. What are you going to do, right? Friday, you have Saturday, you have Sunday. Solve 3 or 4 each day, and you'll be golden. Now, one of your comrades here brought up a very good point, good question, and that is, I mentioned we can do this with the trig sub, and he said, how can you do it, the trig sub, if there is no square root? So I realized that we haven't done any of the trig sub questions that did not contain the square root. So yeah, I understand that the stream is still going for 7.5, but let's sneak in a 7.4 question on the same stream just to get back. So, and I will obviously write it in the 7.4 section and repost that one with new. So we can take a look here. Pick a problem that does not have a square root. Since you asked, 39 has no square root, 41 has no square root. Well, it does, it's actually 3 halves. 43 has no square root.
I can choose any one I want.
Without square root, yeah. Well, 39 or 43, those are the ones.
Whichever one is harder. No, 39.
39 it is. So we will work on problem 39. It says integral of x squared divided by 25 plus x squared, everything squared, and then we have dx. As soon as you see these perfect squares, in terms of x squared and 25, we can unleash trig sub on it, even though there is no square root. So we have 2 legs. We have 2 legs. We have, we'll put this one to be 5, this one to be x, and this one must be square root of x squared plus 25, or 25 plus x squared, it doesn't really matter. Pythagorean theorem, you can't escape that. It must be square root. So now, we solve our trig functions the same way, always towards the number. We have our tangent theta to be x over 5, and we have from there that x is equal to 5 tangent theta, and then dx is equal to 5 secant squared theta d theta, and then we have our cosine theta to be 5 over square root of x squared plus 25, from where square root, you always solve for square root, is 5 over cosine theta, which is 5 secant theta. And here's the trick. You don't need the square root. So, square both sides. That's the trick. And you will get the plane x squared plus 25 without square root is 25 secant squared theta. So now we are supposed to plug everything in, which is integral. We have x squared, which is 25 tangent squared theta. Then we have d theta, which is 5 secant squared theta d theta, divided by 25 secant squared theta, everything squared. All right, so I have 25 squared, that's 4 5s. On top I have 3 5s, so all of it amounts to 1 over 5 outside. I have 4 secants downstairs, 2 secants upstairs, so it stays as tangent squared theta over secant squared theta d theta. I hope I canceled everything right. So let's check one more time. 25 is 5 times 5, and then I have another 5. So in numerator, 3 5s. In denominator, I have 25, which is 2 5s, twice. So 4 5s in denominator, 3 on top, 4 on the bottom. The difference is 1, so 1 on the bottom. Good. We have 2 secants in the numerator. We have 2 squared, which is, sorry, 4 square, which is 4 on the bottom, so 2 remain on the bottom. And now you have the tangent, so that's what I was counting 5s for. I have 1, 2, 3 5s on top and 4 5s on the bottom. Cool? All right. So now I think to solve this, we will simply write tangent as sine squared theta over cosine squared theta, and the secant is 1 over cosine squared theta, and then these die. So all we have to integrate is sine squared, and we're done. One over 10 integral of 1 minus cosine 2 theta d theta, which is 1 over 10 theta minus 1/2 sine 2 theta plus c. Oh no, we have to go back. One more step. 1 over 10. That's inverse tangent of x over something over 5 minus 1/2 times 2 sine theta cosine theta. So I have to replace those now. Okay, what's sine theta? Looking at the triangle, sine theta is x over square root plus 5 over square root. No, plus, times. And then that simplifies, so no square root in the final answer. Plus c.
You missed your other 2 tallies. You have another, you set up another tally system. Yeah,
I thought I did 7 correctly, right? You think that I did 9?
Yeah.
Oh, I'll take it. Full extra.
Then you could erase those other 2.
No, those are wrong.
Oh, gotcha.
So I get to erase 2?
Never mind.
You're messing me up.
Sorry. I'm confused and not labeled correctly. Right school. Hey, Professor?
Yes.
Silly question, but how does... Wait, so sine squared theta goes to 1 plus cosine 2 theta? Because of the trig identity?
Yes, trig identity is sine 2 theta is 2 sine cosine, and then half cancels there. So, yeah.
Gotcha, okay.
This would be it. Oh, that's it for this section. And for partial fraction, now we have the next section.